Now we can discuss about our transaction log file architecture. Okay, so the thing is like the MDF file architecture is kind of like it's a permanent data storage in the pages and extent. Okay, there is not much architecture for the MDF. Like architecture is nothing but the data can be stored in the physical storage in the MDF extensions, and the actual data will be stored in the pages. But now the thing is like the SQL log file behavior and the architecture is very important. Why? Because we are going to discuss now. So this is the you can take like this is the database, and let me take this is the MDF. Okay, so I can take a log file as a bigger one. So now we can go for the our definition. Yeah, transaction log file is the critical component of every SQL Server database that records every modification and transaction. Like as we discussed, right? So each and every transaction that will be recording into the our LDF. Okay. So whatever the data is going to modify, or that may be insert or update or delete, or updating the column or anything modification happen on the of database, that data will be, those modification information will be stored in the transaction log file. Okay, it's a act as a sequential all or nothing. Yeah, so why? Because all or nothing. So why? Because we discussed it, right, kind of a concept called of asset properties. So I have a 10 transaction, it has to execute all the 10 statements. Once the commit happen, then only the data will move from the, suppose like I have 10 statements. 10 statements, it will come to the here. It has to execute all the statements. Once it's commit, then only it has to go. So what are the transactions coming here? In between, I keep like MDF buffer cache. Okay. So buffer cache, like from the page are coming, putting in the transaction log file, and in the statement or transactions, we have everything. All are going to modified buffer cache, and here once the commit happen, all the 10 statement as a single batch, then only it has to commit. So that means it has to execute all to move MDF or nothing. Then why? Because consistent state and record the event of the system failure. As I mentioned, right? So the thing is like it is the system got crashed. So how can we know which data is committed, which data is uncommitted? The thing is like if you going to directly modify the MDF from the user transaction, what will happen? The IO operations will increase, and there is no consistency because the transaction will be stayed in the middle, or uh, it is going to update on the different types of a level. So we don't have a consistency. So that is the reason the SQL server is not allowing any transaction to modify the MDF. It will allow the data to modify in the LDF. Once the data is committed, that will go to the LDF to MDF. Suppose in between, if it crosses, what will happen? Once the server is up, using this LDF, the data will be moving from the LDF to MDF based upon the committed. The thing is like that is the reason we have required one more backup as well. The thing is like what are the committed we have? If you going for point in time, that time uh, we are going to store that particular point in the time. When we discuss about the backups, we can understand for the point in time restore. Okay. So let me go for this actual definition. It is a critical component of the SQL Server database that records every modification of the transaction logs. So the primary function of the transaction logs are to support the database ACID properties. So the main primary function for the transaction log file, why? Because ACID properties. Now let me go for architecture. So the SQL server, what will happen in the background? It will use the LSN number. Okay, the SQL server will use the LSN number. Okay, so log sequence number. What are the transactions are? Okay, it is going to modify or what are the transactions are going to the transaction log file. That transaction log, the transaction statement will identify the LSN number. Using the LSN number, the data will be move forward or roll forward. So each and every transaction will have the LSN number to identify the our transaction. Why? Because I got a one transaction. That the transaction has to modify the multiple pages. So what will happen? That transaction information, it will log to the our SQL server uh, transaction log file. In that, using the LSN number. Using this LSN number, the transaction may be move forward or maybe stay back here only based upon the commit or uncommitted transaction. And the thing is like the same concept, we need to go for wall. So whenever the people are asking for, can you explain the log file architecture? So whenever the people are asking for log file architecture, what we need to do? We need to start with the what is the transaction log file. Then once you give the definition of the transaction log file, the transaction log file is the one of the core component for the database file that will record the all the modifications which are happened, insert, update, modification information that will stored in the transaction log file. This will help to recover the database. That is the main core component of the transaction log file. This transaction log file, it will log the all the statements using the LSN number. This LSN number, using the LSN number, the SQL server, the data will be move forward or roll back to keep the consistency of the data. And also we have to explain the what is the wall concept as well. So here in the log file architecture, we have to tell like definition by definition. One is the what is the transaction log file definition. Then we have to explain the what is the LSN number and what is the purpose of the LSN number. And we have to explain the wall concept. Wall concept we can tell the simple only one statement. Like before writing onto the any modification on the MDF, the transaction will be recording into the transaction log file. Those we can call like a wall. And as I mentioned the previously, like what are the transactions? What are the transactions are coming? Will come here. Will come here. Will come here, right? So commit, commit, not commit, not commit. So transaction log file having kind of a two portions. One is active portion and another is a inactive portion. So active portion is nothing but a uh, uh, come on. What is the active portion? So active portion is nothing but the transactions are coming. Okay, active is transactions are still executing into the transactions that are not committed. What are the transactions are not committed? That may be failed transactions, or that may be still running the transactions, or that may be waiting for the commit. So active portion, inactive portion. So active portion, the transaction may be waiting for checkpoint, or maybe still running, or maybe fail, or rollback statements. Okay. So the active portion is like what are the transactions which are coming from the buffer cache to transaction log file that is waiting for the checkpoint, or maybe that is still running. Like still running means like waiting for the data is committed. Okay. But waiting for the checkpoint committed is happen, but it's not moving to the here. That portion will go for active portion. Still running, like data we have used transactions that not yet committed, and that may be the transaction is cancelled. So that means it has to fail rate. So those what are the portion the space is occupied. Those portions called like a active portion. So inactive portion is like what are the transactions are coming from the buffer cache, those putting into the LDF that was committed. The data is moved to LDF to MDF, but what are the spaces occupied? That portion we can call like a inactive portion. So the basically the transaction log file having two portion, active portion and inactive portion. And now the actual thing is like the transaction log file is divided into multiple virtual log files. That is the important concept. So this is called like a transaction log file. This transaction log file is dividing into multiple virtual log files. The transaction log file is dividing into multiple virtual log files. VLF. VLF. So we have a one number. Okay, we have a few numbers by dividing into the log file. So this log file will be dividing into the virtual log files. This virtual log file depends upon the our transaction log size. The size means like how much data is allocated for the transaction log file. Accordingly, the VLF file can be utilized. Okay, so the VLF can be the transaction log file can be divided into physical virtual log files. This virtual log files we have a number. The number, let me go for a definition. That internally divided into the smaller, and these segments we can call like a virtual log files. Okay, so each VLF contains one or more log blocks, which basic unit of the IO for logging, log blocks act contain the individual log records, and now the maximum size of the 60 KB. Let me check it. See, we already write logging we already discussed. Active log we discussed, and truncation we need to discuss. Okay. Before that, so we covered this one. We covered this one. This one truncation we need to cover. This one also we can cover. So the virtual log files dividing of the SQL server, we have some kind of a how many virtual log files can be divided. So the interview will ask the question, how many virtual log files will have in the transaction log file. So if the growth is less than 64 MB, the log file size is having less than 64 MB, then our virtual transaction log file is divided into 4 VLFs. Okay, suppose, yeah. So this is the transaction log file. I have suppose 64 MB. That time, this log file is dividing into 4 virtual log files. And if the growth is less than 64 MB, create 4 log files. If the growth is 64 from 64 to 1 GB, that will having 8 VLANs. So these numbers we have to remember. Like out of 10 interviews, 2 interviews they may ask, okay, to understand the our how many virtual log files. Why? Because if you having less virtual log files, what will happen? Suppose our SQL, previously I told you that whenever the SQL server is restarted, after recovering the database, it has to scan the transaction log file and it will check what are the committed uncommitted, right? So if the database having more virtual log files, what will happen? It has to scan more virtual log files and that will take more time to recover. Why? Because if you have having 4 virtual files, the transact SQL server go and scan very fast. Those are the 4 virtual log files and it will check which are committed and uncommitted. But if you having like a hundred of thousands of real lives, what will happen? It has to scan entire the all the VLFs, then it has to find which committed, which uncommitted, then it has to go for roll forward and roll backward because it has to go and check each and every VLFs and it will check which are the transactions are committed, which are the transactions are modified. Then it will decide roll back or roll forward. If they are having less number, this process will finish very fast. If you have the more VLFs, what will happen? This process it will take a longer time. Then our database recovery will be taking longer time. So the numbers are uh, if you grow the 64 MB to 1 GB, that will having 8 VLFs. If growth is larger than 1 GB, what will happen? It will create 16 VLFs. Then after that, what will happen? Based upon the growth, it will create. So my transaction log file, at certain point of time, it's 1 GB. But in the future, it will go increase rate. How it will increase? Based upon the growth and rate of growth, it will increase. So from 0 to 64 MB, 4 VLFs and 64 MB to 1 GB, that 8 VLFs. If it's more than 1 GB, that 16 VLFs. So that cover the growth of the size for the example 8 GB create 16 VLFs of size of 18. Oh. So what you mean to say? It will create 16 VLFs, each one of 15 1 MB. So that means the size will be vary. From 8 GB growth, what it will do? It will divide 16 files and each size will be 512 1 MB. See? If the log file having grow to large size, then many small increments, they end up with many virtual log files. This can slow down the database startup. What is that means? We discussed that it has to scan the entire VLFs, then it will slow down the recovery. So that is the reason, as much as possible, we have to keep the transaction log files is minimal. So how can we keep minimal? Okay. So if the log truncation is process is not happening, that scenario, what will happen? The log file VLF will be increased. So here, if you going for here, so the computer transaction will be there. The data will move to here. But the computed data, we can go for inactive portion, right? So the inactive portion, we have to truncate. The truncate means we have to clear the space here. Otherwise, what will happen? The transaction log, let me tell you. So we have a data came, suppose like here, this many VLFs we have. Okay. Data came here and data came here, data came here. What will happen? If it is commit, okay, if it is commit, the data will move to the disk. And what are the VLFs we allocated? That portion will be, it won't release the space. What is that means? Whenever the new transaction comes, it won't take here. It will go for another VLFs and it will check if it is commit or uncommit. The space is occupied, it will go for here. It will go for here. So the thing is like, if the data is committed, but the space is not releasing, then what it will do? It will keep on here. Then it will keep on here. It will go for keep on here. So once it reaches the end of the log file, what will happen? It will look for the log reuse. So initially, what are the VLFs we have? That will try to accommodate for the new transactions. If the transactions portion is inactive, what will happen? Inactive person, it won't take the new transaction. That is the reason it will look for the another VLF. That VLF also may be inactive or active, then it will go for another VLFs. So what it will do, it will check entire transaction log size. Once it reaches the transaction log file, what will happen? It will go and again check for the first. Then it will check for the first VLF. The VLF having committed, but the data is not truncated. Then what is to happen? The data, it will go for next VLF. It is committed, but not is truncated. So what are the VLFs we have? That is active or inactive, but not is truncated. Then what will happen? It will go and create one more VLF. It will go and create one more VLF based upon the transaction log file, what we're going to check the auto growth. So like whenever we creating the database file initially having 64 MB, then we can change the database properties uh, to grow the transaction log file in the disk. Initially, we are not going to allocate the more storage on the for transaction log file. The transaction log file growth will increase based upon the transactions and log truncation. So the log truncation, when it will happen? That log truncation will happen when we perform the log backup. So the committed transaction. Suppose here, this is the committed, this is the committed, this is the committed, this is the inactive, this is the inactive. Come on. This is the inactive, upper arrow we can consider like a committed, inactive. So whatever the data is committed, we can call like a inactive person. This is called like a committed, inactive. Like this is the active person. So what are the, how many we have? One, two, three. Three and one more, four. One, two, three, four. We have four VLF and this much of size is like a inactive. The data is moved for these blocks to MDF, but the space is not releasing. So the log truncation will happen. The log truncation is means like what are the keeping into the here. That means what are the transactions like the transaction ID, old image, new image, and which object and which row it has to modify it. All the transaction will be recorded here. So the page is going to keeping into the buffer cache to LDF, right? So using the LSN number, this LSN number having this many attributes. So what are the transactions came? See, from the buffer cache to LDF, the transaction will come, right? So that each and every transaction will have 128 attributes. So that 120 attributes, like a page number, that is a one attribute, and new image, one attribute, and which page, one attribute, and at what time, one attribute, and which table, one attribute. Like that, we have 128 of attributes will be each and every transaction. So the transaction we kept here, and the data came here and committed. The data came here, committed. The data came here, committed. The data came here, committed. So, and pushing into the data. So, what we can think, our as like a normal, the data is committed. This can be place can be used for upcoming transaction, but SQL Server won't allow. Why? Because data is moved to MDF, but still the data will be sitting into the here. So here log truncation should be happen. If it is not happening, what will happen? Upcoming transaction, SQL Server, what it will do? It will try to allocate the new block. Why? Because the inactive portion is not truncated. So that is the reason SQL Server, it will allocate the new block. So it will allocate the new block up to how much storage we allocated to the database. Okay. So we can discuss when we going for the new database, like a sizes. That time we can understand, but the concept is the truncate. So the inactive portion will be here, right? Suppose if the inactive portion is truncated, when the transaction look for the end of the log file, it will go for the log reuse. If it is, if you have any free space, that will use, right? So here we have an inactive that is not allowing. That is the reason we have a call like a log backup. So log backup will be truncate the inactive portion of the transaction log file. So it's very important for the our SQL server and recovery purpose. Log backup. So the transaction log backup will scan the transaction log file. So whenever we perform the transaction log backup, what will happen? The transaction log, it will scan the entire transaction log and it will take the backup and it will keep it into the one disk and inactive portion will be truncate. The truncate means it will clear the space for the that particular LDF. So that means what are the previously that was filled which committed, that will be take the backup and keeping it to the one storage location. That storage area which will allocate from the upcoming transaction. So the log truncation portion will be happen for the transaction log backup. So the thing is like here truncation. The log truncation cross making the inactive person reusable. So reusable means like to use for upcoming transaction. It does not reduce the physical size, but make the space available for the new log records. So the people will think, okay, so whenever we perform the truncate, this space entire storage is not released from the disk. No, it will the space will be remains on the physical file. But what are the physical file we have that is a free, that is used for reusable for upcoming transaction. So whenever the log backup happen, that will truncate the inactive portion of the transaction log file, and that will free up the inactive portion to reuse the upcoming transaction. That is called like a truncation. Truncation is maintain the task that occurs to maintain after. That is different. Okay, simple recovery model, like I told you, right? This log backup behavior will change for further to changing the behavior for upcoming sessions. Okay, so the thing is like whenever the people are asking for log file architecture, we are able to explain the first what is the transaction log file, and immediately we need to explain the LSN number, and we need to explain the wall concept, and we need to explain the active person and inactive person, and we need to explain the how many VLFs can be created, and how the log reuse will apply, and how many VLFs can be created, and how the log truncation is happen. So all these topics we need to combine and we need to explain. So this is a very important concept for the log reuse. The log reuse, one of the key column we are going to discuss when we transaction log file is full. Why? Because the log reuse is not going to like the transaction log file is full. What is that means? Like what are the upcoming transaction is coming and going to keep the transaction log file? We don't have space. Then we need to check why the log reuse waiting for which state. So the log reuse is coming and checking what are the VLFs is currently occupied, what is happening in the background. Okay. The log reuse may be active person, or maybe replication configured, or maybe always availability configured, or maybe checkpoint is not happening. Log reuse waiting for the different operations. Okay, why the transaction like truncate is not happening? We can discuss when the log file is full. But now you are able to. I hope you people understand what is the transaction log file, and what is the LSN number, and what is the wall concept, and what is the active person, what is the inactive person, and what is the fail statement, what is the running statement, and what is the committed data, and what is the like a truncate portion, how will it happen, and how many VLS can be based upon the virtual log file. This is called like a transaction log file architecture. Let me stop the recording here. Uh, Stop the recording.